Hello and welcome back. This is going to be kind of an introduction to lesson 3.5 using Desmos. And I strongly encourage you to go to www.desmos.com and use the graphing calculator function. And what we're going to do is we're going to put in the generic form of our vertex form of a quadratic relation. So you can just follow right along here. Y equals A, and then in brackets, we've got x minus h. Remember the little hat sign over the 6? Just hit shift 6, and that'll give you an exponent squared. And once to get out of your exponent, you can either cursor to the right or click just after it. I always cursor. You'll notice the cursor drops back down plus k. So there's our general form of our vertex form, y equals a times in brackets x minus h squared plus k. And this is the form we like to use for transformations. Down here, you're going to see add slider AH and K. I want you to select all here, and it's going to create three sliders. Now, the sliders automatically default to 1. Well, H and K's are vertex. We just want to bring those back to 0 to start with. So I'm just, oops, and bring that back to 0. 0. Perfect. And now, really, what we've got is our most basic function of a quadratic equation, which is just y equals x squared. So you can see I put y equals x squared. It's the exact same graph. So this is our what's called our parent function. Now, A, H, and K, we want to find out what each one of these do. And we can do that with the slider. I'll start with H. As we move H more positive, you're going to notice that our parabola shifts to the right. And in math, we say that it translates to the right. So here H is 3. We can see it's moved 3 units to the right, or it's translated 3 units to the right. If we go the other way, it's translating to the left. So this is when h is -3. We've translated 3 units to the left. So h just translates our parabola horizontally left to right. Oops. Always have trouble getting it back to 0, but I like to reset it and just go through one at a time. So that's what H does. Now we're going to leave H alone for a second. We're just going to see what K does. And K is going to be very similar, except it's going to translate our parabola vertically up and down. So as K becomes positive, you can see it translates our parabola up. So here K is 2. We've translated up 2 units. If we go and make K negative, that just means we're translating down. Let's get to 2. So we've translated now K equals -2. We've translated down 2 units. So H and K, they just kind of move our parabola. A, however, does something a little different. And, oh, there we go. Finally reset it. So, first off, A cannot be 0. So, what happens if A is 0? Well, if A is 0, we no longer have a parabola. It's just a horizontal line. Came in. If I can get it there. There you go. So that's what happens when A is 0. All A times x minus h, so all this in here, A times x minus h squared, would all go to zero because zero multiplied by anything equals zero. So all you'd be left with is k. So just for fun, we can move our horizontal line up and down. All right. So a is never zero in quadratic relations. We have seen a at 1. That's our standard. And what happens if we go above 1 is we start to vertically stretch our parabola. So you're going to notice as I get a little higher with my a value that our parabola gets skinnier and skinnier and stretches vertically up. Big stretch. So when a is greater than 1, we get this vertical stretching. Well, what happens if we set a to -1? So there's a -1, and we can look and see here that with a being -1, it's still really our parent function, and we can verify that using the step over 1, down 1, over 1, down 3. And so we've got our basic parabola, but what's happened is because a is negative, that negative causes a reflection across the x-axis. So it reflects across the x-axis. And you can explore that a little bit more. And then as a gets more and more negative, it's still going to do what it did when it was greater than 1, which is a vertical stretch. It's going to get skinnier and skinnier and stretch further and further, but it's going to stretch downwards because of that negative. So I'm just going to set a back to 1 for 1 second because there's one other thing I want to show you, and that is when a is between 0 and 1. Instead of vertically stretching, when a is less than 1 but greater than 0, it's going to do a vertical compression. And so you're going to see it do the exact opposite of when a got bigger. It was getting skinnier and skinnier and skinnier and stretching and stretching and stretching. Well, let's set a to 0.5 here, and you can see as I'm doing that, instead of stretching, it's actually what we call getting vertically compressed. So this one we would say there's a vertical compression by a factor of 1/2 or 0.5. So the closer we get to 0, the wider it gets, the more compressed it gets. And of course we don't want to hit 0. With 0.1 we can see that we are having a vertical compression of by a factor of 0.1 or 1/10. And the same thing happens when a is negative and between 0 and -1. It's just the negative sign is going to reflect it across the x-axis. So this is a when it's positive 0.1. When a is negative 0.1, it looks the exact same except it's reflected across the x-axis. So I'm just going to put right back there. I strongly recommend that you put this into Desmos and you just play around a little bit. And when you're going through lesson 3.5, if you ever want to verify your transformations, just put in the generic form, add the sliders, and then just move your sliders to the numbers that correspond with A, H, and K in your equation to verify. I hope you enjoyed that, and join me for lesson 3.5 coming right up.